Okay, here we go, guys. We made it to the final. Nice job, us. We get to now study for the final exam. And also just, it's really good information to go over what we've learned. So we're going to start with exponent rules. Those were mainly in first semester, but they're so important we decided we'd keep them on the final. So these are notes that you've seen before, so I'm just reviewing with you again. If at any point you want to pause and write these notes down, you're welcome to do that. Okay, so when you combine like terms, the exponents, so this is adding and subtracting. So 2x plus 4x just becomes 6x. The exponents don't change. Okay, when you multiply like bases, so x to the 5th times x to the 3rd, what do we do with the exponents? We add them. So we get x to the 8th. When you divide like bases, x to the 10th over x to the 2nd. Oops, I should make that the 3rd. Okay, when I divide, I subtract exponents. So x to the 10th over x to the 3rd, 10 minus 3 is x to the 7th. When you take a power to a power, so if I have x to the 3rd to the 5th, when I take a power to a power, I multiply my exponents. If there is a product of a power, such as 3xy to the 4th, all of it to the 2nd, then we're going to take 3 to the 2nd, x to the 2nd, y to the 4 times 2, because that goes back to a power, so that's 8. So that'd give us 9x to the 2nd, y to the 8th. So we have to take everything to that power of 2. That's what it means by a product of powers. Any non-zero number to the power of 0 is 1. And if there is a negative exponent, okay, it goes to its opposite place. It goes to opposite place. How many p's do you need in opposite? Opposite place. Okay, so if I have x to the negative 5, that gives me 1 over x to the 5th. If I have x to the, well, we're going to practice some more in just a bit. Fractional exponents. Now, from what I understand is you might have seen some on the EOC about fractional exponents. So if I have a fractional exponent, x to the 2/3, the bottom number, the denominator is the root, the index of the root, and the numerator is the exponent. So if I have this, that's the cube root of x squared. Or if, so see how that works? So if I would have had the 7th root of x, I would write that as x to the 1/7. Okay, so that's what we mean by fractional. So here's an example, and then we'll do some more on the next page. So I have 12 over 14, x to the negative 3 over x, y to the 7th over y to the 2nd. And this is the problem that gives you 3 problems in one, 3 for the price of 1. So I have this problem, 12 over 14. I have the x's, and I have the y's. So let's take all of it. 12 over 14, what are they both divisible by? I can divide both of those by a 2. So I get 6 and I get 7. Now I look at the x's. Me personally, I like to take care of those negative exponents. So it's in the top, I'm going to move it to the bottom. And I already had an x there, so I'm going to let that stay. The y's. Well, where is it bigger, top or bottom? Bigger in the top. So I'm going to subtract 7 minus 2 and get 5. Let's simplify that bottom. So we have 6y to the 5th that stays. 7, when I multiply like bases, I add my exponents. Okay, let's look at the next page because I think we have a couple examples on there that might be kind of helpful to look at. Let's see if we have anything that we've got. Not anything too major. Okay, so I wish you were here so that you could pick some problems with me. Let's just pick a couple. So here we go, x to the 8th, x to the 5th, x to the 2nd. So x to the 8th hangs out until I actually multiply this one. I'm going to take a power to a power and multiply. Now when I multiply, I'm going to add. So that's 8 plus 10, which is 18. Hopefully you remember that. Okay, if I have something like this, I can simplify the inside first, or I can take everything to the power first. It doesn't make any difference. A lot of times students will take everything to a power. This one might be simpler to simplify inside first, which is what I'm choosing to do. Because look at the 10 and the 2. That can reduce down to a 5. Look at the x's. Where's it bigger? In the bottom. 8 minus 5 is 3. The y, stick that up top. Now I'm going to take everything to the third power. That's probably a little easier. 5 to the third. If I take an exponent to a power, I multiply. 11 times 3 is 33. Over x to the 3 times 3, which is 9. We're not going to do this problem. So 5 to the third, that's 5 cubed, that's 125. Y to the 33 over x to the 9th. And that would be my answer. Okay? But I just kind of go through some of the rules. So watch those negative exponents. I could have taken everything to the power first if I wanted to. Okay, there's your brief review on exponents. You'll ask me more questions when you come across it. And like I said, this is what we're going to be covering. So we did exponent rules. Yay, covered that. Let's look at Pythagorean theorem. Pythagorean theorem is where you have a right triangle. So this is for a right triangle. And this is really helpful, and I'm glad it's on the final because next year in geometry you're going to see this. Remember, for Pythagorean theorem, it's going to be a squared plus b squared equals c squared. C is always the side that is opposite the right angle. Okay? So this is my hypotenuse. So for instance, on this problem, one of these is a and one of them is b, and it doesn't matter. So I have 6 squared plus 8 squared is equal to x squared. And this one turns out nicely, I can tell you that. It's 36 plus 64 is equal to x squared. So that's 100. That's equal to x squared. Now we know that if we have a squared term, we have to take the radical. Now here's an interesting thing that we didn't have to deal with before. We know that if we put a radical on, we have to put a plus or a minus. So we're going to get plus or minus 10, right? Now look at the problem. Is this side going to be negative? Is that going to be a negative 10 for length? No. So my answer is 10. And that's one of those examples. Yes, we have to take the square root, but we're not going to use a negative side. Go ahead and try this one. Pause yours and try that one. So hopefully you realize that this is the hypotenuse over here. That's c, so it goes on its side by itself. So x squared plus 4 squared equals 12 squared. So then I'm going to get a 16 and a 144, subtract 116. I get 128. I take the square root of both sides, put a plus or a minus on it. Even though we're going to use the positive side, it's just good habit. When we take the square root of 128, we get 11.31. So we're going to round that to the nearest hundredth. 11.31. If I round it to the nearest tenth, it'd be 11.3. Okay? We're only going to take the positive side because we're not going to have a negative length of a side. Now the other thing that's going to show up in Pythagorean theorem is given a real life situation. So I found some of those too, where there's a real life situation that we're going to look at. The bottom of the ladder must be placed 3 feet from a wall. When you get to the word problem of Pythagorean theorem, the first thing you want to do is you want to draw a picture. And I'm not talking about that it has to be an exciting picture. Bottom of the ladder must be placed 3 feet from a wall. So here's a wall. You can make it brick, you can make it whatever. Here's your ladder. Okay? There's your ladder. You just have to draw enough to know what it's talking about. Place 3 feet from a wall. So this right here is 3. The ladder is 12 feet long. How far up from the ground does the ladder touch the wall? So there's x. So x squared plus c squared equals 12 squared. Okay? How far from the base of the house do you need to place a 15-foot ladder so it is exactly reaches the top of the 12-foot wall? Okay, so I have a 15-foot ladder. I wanted to reach the wall. That's 12. How far do I place it away from the wall? So this one, I'm going to have x squared plus 12 squared is equal to 15 squared. And then you solve that. Okay? But we already practiced that, so I'm not going to take up all your time. Okay? Next thing we're going to do, those are our first two topics, Pythagorean theorem. Function or not a function, based on a table, graph, order pairs, or mapping. So I just came up with some. I found some on the internet. We're just going to look at those. This is a mapping. Okay? -1 goes to -2. Oh, wait a second. Let's refresh our memory. A relation is a set of any order pairs. A function means that we have to have exactly one x value for every y value. Okay, exactly one x for every y, but y can be whatever darn well pleases it, a lot of times is. But x, another way to think of this is that x can't repeat. X can't repeat. I don't know what that word is. Okay, x can't repeat. Can't have more than one x. Okay, so here I go. Negative 1 goes to negative 2. 1 goes to negative 1, and it also goes to 0. So if I were writing this out as ordered pairs, that would be negative 1, negative 2. This would be 1, negative 1. This would also be 1, 0. Ta-da! Not a function, not a function, not a function, because right here. Okay, it can only go to 1x value. Another thing is a vertical line test. We can only touch the graph once. So look at right here. Fails the vertical line test. This is not a function. Not. Okay. Look at this. If I'm given a table, look at those x values. Do you see any x values that repeat? Wham! Right there. So, not a function. Are all these not functions? Oh, vertical line test. Here we go. Yep, passes. Oh, fails miserably. Passes. Let's look on the back side. So you can see what I'm saying, that we're going to be giving you ordered pairs. Oh, look, here's ordered pairs. Look at those x values. Any of those x values repeat? Nope, this is a function. Function. Okay? Look at those x values. Any repeat? Nope, that's a function. Is this a function? X value, x value. Oh, yeah, that's a function. Function? Yep. Function? Yep. Function? Yep. Well, that's a close one. Yep, still a function. This is going to be, nope, right there. Look right there. It fails. Oh, they're saying that it curves. That one's pretty close. We won't do anything to you. So these are all functions. Okay, you just have to be able to look at it, and you're going to have to match those up. So just look at the x values and look at the vertical line test. Okay? Next, identifying graphs, whether they're linear, quadratic, or exponential. So, if I give you these graphs right here, what is this? Well, it's not this. This. And if you're in doubt, go with what you know. You know this is a line, so that's a linear. This, my gosh, hello people, I hope you know that's a quadratic. We've been doing 20 million weeks of those, it feels like. So that's a quadratic. So guess what this is? That's right, this is an exponential. It's also, this is an exponential decay, just in case you're wondering. An exponential growth would have gone up like this, and what happens, and I'm sorry we didn't have more time, it comes along down to it and never crosses a certain axis called an asymptote. Anyway, so if I had a growth, which is what COVID-19 was at first, exponential growth, right there. It just kind of goes up, so it goes really close, and then wham, goes way up. Okay? The next thing on our list was to calculate slope. Not really sure where that's on the semester exam, but it doesn't hurt to go over it. To find slope, remember how to do this? That's right, subtract y over subtract x. So the change in y over the change in x. So 3 minus negative 9 over 2 minus 5. I take my y values and subtract, and my x values and subtract. And here I'd get, what, 12 over negative 3. So my slope is negative 4. Okay? So that's slope. Hopefully you remember that. You're going to be taking a practice test, and you're going to come back with more questions and find out which ones you get and don't get. Next thing we're going to do is identify polynomials. This is a little more recent. We're now back into this semester a little bit more. So remember, if the degree is 0, it's a constant. Degree is 1, it's linear. 2 is quadratic. That's the only one that doesn't make a lot of sense with what we're doing. Power of 3 or degree of 3, this is a cubic. And I doubt if you'll have it, but power of 4 is a quartic. That's by the degree. The degree, remember, is what is the highest exponent if there's only one variable. The highest exponent is going to determine your degree and what it's called. And that's what you're going to be asked to do on the test, is name something. Very similar to the test where we ask you have to name which one is like a quadratic binomial or something like that. Okay, so now if I have one term, that's going to be a monomial. 2 terms, right? Binomial. 3 is a trinomial. 4 is a polynomial. 4 and up, okay? 4 and up is a polynomial. These are the only 3 that have names. Now with polynomials, we're going to have to know how to add and subtract. So if I take 2x squared, we're just going to do subtract, because addition, you're going to see here pretty soon we'll take care of that. Minus 5x plus 4 minus 3x squared plus 7x minus 8. So if I'm going to add, I'm just combining like terms. If I'm subtracting, I'm still just combining like terms, but I have to remember I'm going to subtract everything that is in here. So I'm going to subtract everything that is in here. What I like to do is I like to go through and change my signs. I'm going to change this to addition, everything in here to its opposite. Then I can just combine like terms. Make sure it's in descending order. And that's my answer. Now, if it's multiple choice, you might just see a negative x squared instead of a negative 1. If I'm going to multiply 2x plus 5, 3x minus 6. Nope, minus 7. So after I write this, I would strongly recommend you just stop the video, do it on your own, multiply it. Okay, you know how to do this, people. Be brave. Okay, so hopefully you've paused. If not paused, go and multiply and come back in. Okay, I'm going to go now. So I'm going to take 2x times 3x, 2x times 7, right? So I get 6x squared minus 14x. Now I do the same with the 5. So I get 15x minus 35. So I get 6x squared plus x minus 35. That's my answer. Okay? So that's multiplying. Now, you can also multiply 4x plus 2, 3 times 5x minus squared minus 3x plus 8. And now you're going to just take 4x times everything and 3 times everything. So you're going to get 20. And again, pause yours and try it on your own. Now I'm going to multiply 3 times everything. Now I'm going to combine like terms. There's nothing that combines with the 20x cubed. Hey, I dropped an x squared someplace. That right there. I knew that I had to have an x squared. So now that's going to give me plus 3x squared. And 32 minus 9. Oh, crud. 32 minus 9. 23 plus 24. And if I would say to you, find the coefficient of, like up here, if I'd say find the coefficient of the x squared term, that'd be 6. What's the coefficient of x? 1. Coefficient of x squared? 20. Oh, that's x cubed. Coefficient of 3x squared? 3. Coefficient of x? 23. Okay, that's what we're talking about as far as coefficients. So that's multiplying. Now you could also have, as far as multiplying, you could have something like 3x minus 7 quantity squared. If you're going to do that, either do the shortcut or just write it twice. And multiply. Okay? When you multiply, you're going to get 9x squared minus 42x plus 49. That would be your final answer. Yes, I did the shortcut. Okay? So let's see where we're at. We did adding and subtracting polynomials, identifying them. That means like a quadratic monomial or something like that, being able to identify. Then you're going to factor. And remember, to factor, you can just make your x. Make your x. To factor, you make your x. You multiply a times c. We've done that just recently. If you look at the review for solving, we did factoring. So look back at that factoring. And if you need some more examples, let me know in class. That's what class is for on Friday and Monday, to get ready for that final exam. Okay, and so that's factoring. Quadratics. With quadratics, I just did in detail. But identify the parts of the intercept and the vertex. Hopefully you remember which ones. Those are the x-intercepts. What's the vertex? Matching graphs, standard form, vertex, and factored form. So you'll need to know, remember standard form. Y equals ax squared plus bx plus c. Vertex, y equals a times x minus h quantity squared plus k, and then factor form y is equal to x minus p, x minus q. Also in quadratics, a couple things. One thing that I would, either you need to know how to find the vertex of an equation given standard form. Remember the x-coordinate of parabola, the x-coordinate of the vertex is going to be negative b over 2a. The other thing you're going to do with quadratics is, let's say that we have a graph. It looks something like this. Okay, they're going to ask you to identify the vertex. Give that as an ordered pair. What are your x-intercepts? And just look for the directions. They might ask it for an ordered pair, or just what are they? So, is this a maximum or a minimum? Just things like that. And watch those videos from Monday and Tuesday. The last thing we're going to do is actually one of the first things we did for the semester was to solve equations, solve systems of equations, and then also do a word problem. So let's refresh our memory on that. That's been a little longer ago. So what we're talking about here is solve systems of equations in two variables. Remember, there's three different ways. I could graph it, so I could graph these two lines, find out where they intersect. That's not always the most efficient. The other thing is I can use elimination or substitution. So I'm going to take this problem and show you how to do it either way. So if I'm going to do elimination, which is my very most favorite, it's not always conducive, but this one is. And then I'm going to show you by substitution, which is a fine method. It's just not as much fun. Substitution. Okay, so if I'm going to solve by elimination, what I want to do, oh, this one is so easy by elimination, it's not even funny, is that you want to find one of your coefficients. So here my coefficient 1, here's coefficients 2. If one of my coefficients are the same number opposite sign, I can just add. See how this is a negative 1 and that's a positive 2? So on this one, I can just add. This gives me 3x. My y's eliminate and I get 3. Do you remember this? Then you divide by 3 and we get x is equal to 1. Once I have x, I plug it in and I find y. Okay, so my ordered pair, where they intersect, would be 1, 2. So that's elimination. I'll try to find a harder elimination one in just a second. Now substitution, we have to get the y, one of the y's by itself. So I'm going to actually take the second equation, 2x plus y is equal to 4, and I'm going to get that y value all by itself. So I get y is equal to negative 2x plus 4. Then I take this and I plug it into the other equation. X minus y is equal to negative 1. So what I do is I take this equation and in place of y, I'm going to put a parentheses and I'm going to plug in what y we just found out y was equal to. Negative 2x plus 4. Now we have one variable, one equation. Oops, sorry. So I took and plugged this in to this equation. Now we have one variable, one equation. We can just solve the equation. Don't forget to distribute your negative there. Combine like terms. And of course we get x is equal to 3 once we have x, sorry. So I solved that whole equation for x. Once we have x, plug it into any of your equations. I'm going to plug this into here. Y is equal to negative 2x plus 4. And I'm going to plug 3 in for x. Well, why'd I come up with a different number? Hold on. I'll find it. I'm sure you already found my mistake. It's right here, people. Okay? 3 divided by 3, last I checked, was 1. So I should have plugged in 1. Y is equal to negative 2 times 1 plus 4. That gives me negative 2 plus 4. That gives me 2. So I get my same answer that I got over here. Okay, let's find one that's a little yuckier with elimination. So we're going to look at these, and it actually says solve these by linear combination, which is elimination method. So sometimes it's called linear combination because you're combining two lines, two linear equations. So let's just look at a couple, and we're not going to solve all of them because I don't want to take up all your time. But see how this one, see how I have a 1 here and I have a negative 2? If I would multiply this equation through by a 2, I would get 6x plus 2y is equal to 10. 6x minus 2y is equal to 4. See how my y's would eliminate, and I'd get 12x is equal to 14, yada, yada, yada. Okay? Let's look at this one down here. Now, in 27, we can't just multiply one equation. We're going to have to multiply both equations by something. So if I were eliminating the x's, I'd multiply the top one by 3, the bottom one by 5. One of them would be negative. Or I could eliminate the y's, multiply this equation by 7, because it's down here, and this one by 2, making one of them negative. Okay? And then you add. The other thing with solving word problems is that we're going to have, solving systems is we're going to have word problems. So we would have a word problem. We have to set up the equations first, then we have to solve it. Now, I will tell you right now that on the semester exam, we make the equations where you're going to, it's going to be a multiple choice. So be very careful, because remember, we're the one who chose those, so hold on. So the best way to approach it, if we're giving you options, you want to make sure that you come up with the equations first yourself. So let's take, for instance, number 40. Tickets for the homecoming dance cost $20 for a single ticket or $35 for a couple. Ticket sales total, $2,280, and there's 128 people that attend. So do you see one equation is going to be how many people attend? Okay, and one is going to be what is the total amount. So we have single people, so we'll call that S. And then we have a couple, and we're going to have couples, and we're going to get that those are a total of 128 people. But a couple is going to be 2 people. Okay, so we're going to have singles, and we're going to have a couple. Then we're going to have that the total, so it's $20 for a single ticket, or $35 for a couple's ticket. And you would have to solve this. Now, this one lends itself to substitution because you could solve for the S and plug it in. But you could multiply this equation. You could multiply this equation by a negative 20, therefore eliminating your S's. Okay, so this is just a quick review of what you're going to be, what's going to be on your final exam. And the other thing is discriminants, but we've just recently gone through that. Again, look at those Monday and Tuesday videos about reviewing those. Okay, that's what's going to be on your semester exam. Tomorrow you're going to do a practice test. And then we're going to answer your questions the days after that. So thank you very much. And if you have any questions, you know where to find us.